Hello subscriber, we are gonna talk about the operational amplifier or OPR, AMP of in a short form. And this in the works horse of analog electronics. The operational amplifier is a type of amplifier. An amplifier is anything that you put an electronic signal in. You get out larger versions of signals, so this will be amplifier within a sum of a certain to gain, and if it is puts a single signal x here, usually a voltage or a current, then the signal comes out there in a times to x time, and that what mean by amplification. And the signal that I have shown here is an x, is an a thing that will be interested in. It could be a voltage or a current. When we put through an amplifier, you get a large version of it. So this is a really a common activity in electronics design. Now we can talk the special about an operational amplifier, and the symbol of that we use. The operational amplifier is in a triangle. It is a two inputs, one is a plus and input and one is a minus input, and it has been output, and also a two power supplies to it. There some of a sort and the plus voltage that goes into and come a sort of a minus voltage. So this is the abstract value for any OP or AMP. So we can say in the word OP or AMP with some of a specific property in the mind. One is a OAP have a high gain, so in case of high gain, usually within a symbol A, something like a 10 to the 15, 10 to the 16 really is a high. And other things that about we talks about OAP or AMPS is that there is a feedback circuit. We will talk about the feedback in the next couple of a video and what then means. But the application of AMP or a third, that is a diatribe about OAMP amplifier, is that they have a kind of input. This kind of input there is a referred as a differential input. So the OMP usually different input that is oppose something we call a signal and wire, and a differential in means it says have a reliable that voltage here. We will call this V out. We will call this is a V plus, and we will call this input V minus, and the differential input means that V is in equally against times V plus minus V minus. So the output signal here is an operational difference in the voltage and signal. Here we are gonna make of a plots of this equation right here, just so we get the good idea so what look likes. And then x is a V in a V voltage wherein especially equal to the V minus V plus and V minus, that will be input in the signal to the ampere. We are gonna apply to the gain the factor to get out the V. So we call this is a sum like this. It's gonna be a very steep line and the slope that lines, and the slope of a is a, so we slope is going to the 10 to the 5th or a 10 to the 6th, some of like very verticals. Now one property of that out is in the come and can't go above in the below power supply voltage. So of a plots and calls a saturations. If the V outs and up to the V plus, we say the saturation. it's look like is gone basically here and there, and the voltage value, its power has been minus supply. This voltage writes here in positive supply, but our range of this between those points quite linear and goes through the zero. Is this where has been utmost be a time? So now I gonna talk to the little bit about the detail about what is the symbol means here and what's the inside it, and how is actually connected up to the circuit. So we talks about the behavior of an amplifier. This is a V plus and V minus and the V out. This one of a most we need to know, and this is a current, this is a right here, and this current is right here, so the amp is a zero, no current flowing is here. So this amplifier is just sending the voltage at these points, but no current flows. So the second property of an amplifier is a first of a voltage behavior. V is equal to the gains of a plus and the minus. In other way we can't write this is a V out of a equals of a, where V is of course equal to the A plus A minus. So here two electrical properties that gonna allow us to analyze these circuit, and analyze these circuit is actually gonna be a pretty simple. So the probably wondering what inside what going to the here, and so what inside here is somewhere between a B's or a 20 or a 50 or a so the transistor and the resistor, sum of a capacitors. These are really complex design for right now. If we contracted on two property that have, we will able to use these circuit even without understanding externally what inside us. So first to says the differential amplifier within the really high gain, and just knowledge we can work out these circuit work out. So the limit and got a couple of more details in the high and actually hooked, and the A plus terminal and the minus terminal. There is a more terminal in this. There is a power supply like this that will be plugged in between V. There has been a minus supply, typically minus supply V, and there will be a grounded pin, and this grounded pin like that, and when used in a circuit there will be out of inside there, and we will be a 20 or a 12 volts or a 12 volts is a really typically value, and there will be one of these. This is a plus 12 voltage supply as well, and connected to together in the node right end will be grounded the node their voltage reference, and these guys will be hooked like this. The power of a supply will be hooked in that, and so the respect of a grounded at least 12 volts, and the node grounded into the plus volt, and a grounded is the right of a middle. When the measuring you will be measures with the respect of a ground node for the voltage in the measures plus minus V and right here, and when we gonna be here is gonna assume that they are a stuff and always hooked up, and we are just gonna use even a simple symbols and just allows for a hooked in the way. And there will be things in the keep in the mind. There is a large minus voltage, there are the large of a plus voltage, and grounded level, and the nodes is a right between a positive voltage in the high on a page, negative voltage is a low of a page, and the V out can goes both positive and negative grounded, so that the voltage frameworks to be keep in your head. And amplifier that has been looking at here has a simple like this, and we should be again time people be, so this a different put will be here in the way. One of the way think about this is a tool to at the way to change the voltage into the simple modifies of output later level in this. So if you change it in the V, because it's plus sign, and that will be V in the ghost way, and if I change it our V minus and the V is the negative input, and if this goes in this V and gone at that, and so that inverting it's a sum of inverting inputs and the like as input, so the non-inverting input goes up, and inverting, if you goes to inverting into the, you will go in opposite direction on output. Let's positive input, the non-input when down in this, then that means there should be a V will gone to the same thing here, gonna run into the colors. Let's do the same thing for a inverting input. If you inverting input goes down, within it goes up and it goes in the opposite direction. That way they think about the symbol, and when you see it a schematic page, you will these signals, positive or a non-inverting signal goes in the same direction, inverting signals in directions. Okay, here one final trick I want to share with you, something to be aware. You have to gonna see a symbol like this on a page. This the same amplifier, it's the same amplifier written on a page when a negative with an inverting symbol on the top and non-inverting symbol on the bottom. So as looking at the schematic, and there is an amplifier in it. One of the first thing you gonna do it in a just a glance in the see what order these symbols are in, it does in this or it does not look like that, and the keep that in the mind as you are reading the circuits and trying to understand what is it does. Okay, let's move on and build a sum within our own amplifier. Please subscribe my channel to get the more videos like this. Thank you.